Hello everyone. Welcome to this second lecture video in the course series on hands-on training on MATLAB and Simulink for electrical engineers. This is the second lecture of this series. In the previous video, in the previous lecture, I discussed different uses of MATLAB and Simulink, why it is so widely used in the industry and academia, and what are the different components and different toolboxes used in MATLAB. So moving forward in this topic, in this lecture, we will discuss the first and foremost, the basic um, use of MATLAB is plotting, formatting, and exporting. So what does these three terms mean and how we can do these things in MATLAB? I will show you in this lecture through hands-on code. Now we are in the MATLAB software homepage. So this is our homepage in MATLAB software. Whenever you open the MATLAB software, you will get to see this screen. So I have already, due to time limit, I have already written a code here. This is a 38 line code, and I will make you understand step by step what is the meaning of each line of this code. As all of you are aware, but I am again revisiting the basic concept from previous lecture, that this window is called the MATLAB script window. On the downside, you are seeing command window. On the left side top, you are seeing the folder or the directory of the MATLAB software current path. And on the left side bottom, you are seeing the workspace, which is the live variables which are generated or used in the MATLAB during the execution or simulation of any models. Okay, so these are the four main components. Now, step by step, we will see the code which is written in this MATLAB script. Here you can see I have not saved this file yet, therefore it is showing as untitled. So for example, I am saving this file. You can save this file using this button given on the top left side, or you can use Control plus S. So I am using Control plus S to save the file. So this will prompt a dialog box, and in this dialog box you can give any name according to your wish. Only there are two conditions which should not be violated. First condition is that the name should not begin with any number. Okay. Second thing is that within your code file name, you should not have a space in between. So these are the two basic conditions which should not be violated. So I am saving this code as my second code and hit save button. So now you can see that file name has changed. Now jumping directly into the code, you can for your appearance, if the appearance is not suitable for you, you can undock this dialog box. Like there is a option undock my second code.m. So when you click on this, your code will be undocked from the command window. So it is now free to shift to any place. So for example, you are working simultaneously on multiple codes, so you can undock all the codes, and as per your convenience, you can place those undocked windows on the screen. So this is the undocked code. Here you are seeing the first line. This on the left side you are seeing the number of instruction, means line number. On the it is given on the left side. On the right side you are seeing the instruction. So in the first instruction or the line number 1 is starting with a percentage. So what is the meaning of percentage? Is this line will not be executed, means it is a dummy line. This the lines, the codes which are starting with a percentage symbol, they will not be executed. So first line number 1 will not be executed, line number 2 is blank, line number 3 has CLC. So you can see here that CLC stands for clear screen. Clear screen. So when you, for example, I am going again to the command window. For example, I am writing here a equal to 1 and I am hitting enter. So when you hit enter, that the compiler processes this instruction and it finds that a is equal to 1. This is just one instruction. So this instruction is executed. Results will be displayed on the command window and the result will is saved temporarily in the workspace. So here you can see on the left side bottom, you are seeing the workspace has a variable named a, value is 1. So for example, I can use multiple times to execute small instructions directly in the command window without using MATLAB script directly. So when you are using directly the command window, your command window will be cluttered. So you need to clean this command window. For cleaning, you have a simple command which is given as CLC, all small CLC. When you press enter, your command window will be cleaned. Your command window is now clear, but whatever instructions you have already executed, it will be saved in the history. So where we can find the history of the command window. So when you are in the command window, you have to click on this command window and you will see some cursor which will be blinking on this command window. So now you can press the up arrow button. Understood that when you are in the command window, you have to click in the command window and your cursor should start blinking in the command window, means your command window is ready to take instruction. Now you want to extract previously executed commands from the history. So history will be accessible using the up arrow button in your keyboard. So this is I am pressing the up arrow and down arrow directly to run any code from the previous. Okay. So for example, I have selected this VER. Now I press enter. Then your command window will generate the result from this executed instruction. So it is very simple. Now, if you want to again clear this command window, you have to press CLC. Again, there is one another function or command which is called clear all. So clear all means everything will be cleared from the workspace, only from the workspace, because to clear the screen, to clear the command window, you have CLC, and to clear the workspace, because here, for example, we have many suppose there is a situation that we have many workspace variables, temporary variables, and I want to delete the workspace directly using command window. So I will use this command clear all and then hit enter. What will happen? Your workspace will be empty. Your workspace variables will be deleted, but your command window will not be cleared because you are using clear all. Again, if you use CLC, then your command window will again cleared. Okay. Similarly, there is one command called close all. So I will also demonstrate what is the meaning of close all. So for example, I have multiple scripts open. So then if I press close all, then my uh, docked M files will be closed. My docked M files will be closed, but other undocked files will not be closed. So in this scenario, we don't have any docked file. So therefore, we can skip this instruction. Okay, so again, for clearing the command window, we can use CLC. So now directly coming to the code. So you have understood the meaning of these three lines. Now moving to the step 1. So step 1, you can write the codes in such a way that it is easy to understand by someone else, someone layman. So for example, if I directly write like this, so it is very hard to understand that what is the meaning of line number 8. So therefore I have introduced line number 7 to explain what is written below the line number 7. So this line number 7 is creating a time vector. So first of all, I should explain what is our objective today. Our objective is to create a plot, a basic plot, which can be used in publications, in journals, in presentations, in any type of demonstration based activities. You can, in posters also, you can use this type of plots. So I will first create a plot, then I will do some formatting in that plot. Formatting means the changing of font size, the changing of font type, different colors used in the plot, different colors of lines, different thickness of the line, uh, and many other things. So these changes will be done through formatting. And when you are ready with the format which you expect to be presented, then you can directly export that file, that plot file or that figure. Directly you can export as a PNG or JPEG or SVG or any other format, whichever format you want. Nowadays vector files are more used, but they are heavy in size, and therefore PNG as an alternative, PNG portable network graphics, that format is pretty good for publications. So around 300 dpi to 400 dpi, or if you want a high quality picture, then go to 600 dpi or above, you can also go. So you can set the dpi, dots per inches, in the while exporting the image. So you can directly export your image to a folder in your computer, local computer. Okay. So for that, we are first creating x-axis. So our x-axis is the time axis. In our y-axis, we will create two overlapping signals. One will be sinusoidal wave of 50 hertz. Another one will be sinusoidal wave of 100 hertz. So different frequencies in the same plot. So you can directly differentiate between those two plots. So there is one catch. If you I have already saved this code. I have already saved this code. So you can see the name is appearing here, mysecondcode.m. So if you run this code, then your whole code will run at once. Your whole code will run at once. In a single run, it will uh, execute all the 38 lines till here, and it will generate the final output. So our final output is the exported graphics. But if you want to debug, for example, if I want to debug this code one by one in step by step. So in this code, I have multiple steps. So 7 steps I have. So it is possible that in some of the steps there is some error. So for example, in this step only, step 2, I have some error. So if you run this code, due to error in the step 2 only, your code will not be executed further. But it can be noted that you don't have any error in the further downstream of the code. So it is better to break your whole code into small sections. So small sections you can break your code, and then you can run your sections separately. So for example, if you want to run section 1 first, you can run. If you want to run section 8 or section 5 first, you can run that section. So you are free to run or execute any section depending on your debugging. So now we will see how to break a code. So this whole code is a single piece of object. So we want to break this object into separate executable sections. So how we can do that? There is one difference. When you write single percentage, it means that you are um, eliminating the that instruction from the executables. So you don't want to execute that line of code. But when you give here double percentage, so you can see that line has become bold. Double percentage, it means that line has become bold. So it means that you have created one section. Now this is a single piece of code, but it is now a one section also. This is one complete section. Earlier it was not a section, it was just a code. Now if you press double percentage, then it will become one complete section. Again, if you want to break the code in more number of sections, you can use multiple percentages. So here you can see when I am uh, not using double percentage, so there are no breaks in the code. Whenever I am using double percentage, there are two different sections. On the left hand side, you can see there are two sections currently. So for example, I have something like this. So if we have already something in our workspace, if we have something any already there in the workspace and command window, and if we run this code, so here you can see, if I run this section, so I am not running the complete um, code, I am running a portion of the section. So for example, I am running this particular section, so I will click on the run section button. Then you can see all 3 lines of code are executed, because you can see that screen command window is cleared and workspace is also cleared. It means that your code is working perfectly. Now, so for example, I am now creating multiple sections here. For each step, one section. For each step, I have created one section. So first section, if I want to run, then run section. And if you want to run this section and go to the next section, then you can click on the run and advance. So run and advance means your cursor will be automatically moved to the next section. So now if you create, if you run this section, then you can see that line number 8 is executed. Line number 8 is executed. It means that t is equal to 0 to 0.1 with a line spacing of 0.001, means this is the resolution and this is the zero scale and this is the final scale. So you can verify this by going to the workspace, means a new variable of t has been created with a size of 1 cross 101, means it is a single column vector. Again, if you want to run and advance, then you will get to this section, step 2. If you run this section, then there are no errors. There are no errors means it is working perfectly. So now you in workspace, there are two more variables are created. You can verify from here. Two more variables are created, y1 and y2. y1 and y2, both, all the sizes are same. So on the x-axis we have time as t, on y-axis we have two variables, y1 and y2. You can see all the sizes are same. Now if I want to run the step 3, it means that nothing will be generated but a new figure is created. New figure is created. Inside that figure we will generate some plot. So you can run and advance, and then a new figure is created. This is a blank figure. Inside this figure there is nothing. Inside there is nothing, but you can see the figure is created and the size of the figure is fixed. So the size is, width is 6 inches. So this is the in the line number 18 it is given that 6 inches is the width of the figure and 3 inches is the height of the figure. Now again, if I run and advance, I am in the step 4. So what will happen? I will generate the plot inside the figure. So it is what it is doing, it is generating some plot inside the figure. So here you can see the blue line in line number 21. It is generating a plot where x-axis is time, y-axis is y1, and y1, what was y1? y1 was sine of 2 pi 50 into t, means it is a sine wave of 50 hertz signal. It is a sine wave of 50 hertz signal, means there is 20 millisecond of time period. So the blue line is the time period of 20 millisecond. Next, we are creating a command called hold on. Hold on is used when you want to plot multiple lines on the same plot. So if you want to plot 4 lines in the same plot, then you have to use hold on 3 times and 1 time hold off. Otherwise, you can also skip the hold off command, but hold on is very important to hold the plot until you do not get the final line which needs to be plotted on the figure. So here you can see blue line is a solid line which is y1, which is for y1, and the red line is the dotted line which is for y2. Both are different signals plotted on the same figure. Now moving to the step 5, we have to format the plot, means x label, y label, and title and legend and grid. So these are the 5 key formatting parameters, which is x-axis labeling, y-axis labeling, title, Legend means legend is a representative of the signals or lines which is already plotted inside the figure. And grid on is used when you want to show the horizontal and vertical lines in the plot. So now I am running the step number 5. Then you will see some changes in the plot. So you can see the time axis, x level has been updated, y level has been updated, title is changed, legend, we have two signals, therefore we are getting two legends. Legend name you can change from here, it is customizable, it is manually customizable. And grid on, so you are getting now some gray color lines behind the plot, which are vertical and horizontal. Now going to the next step, if you run this, it will change the x limit and y limit. So if I run this, it is changing the x limit and y limit. So earlier it was set to -1 and +1. Now y limit is set to -1.5 to +1.5, and x limit is also changed. Earlier it was 0 to 0.1, now it is 0 to 0.05. So like this you can change your appearance of the plot, and you can make your plots beautiful and technically correct. Whatever you want to show in your plot, you can insert many things like some diamond shape or some triangle shape, some round shape, some arrows if you want to insert, some annotation if you want to insert. Everything is possible in MATLAB using some proper structure of commands. So now if you are ready with your plot, so this is a raw image. You can directly copy from here also. You can directly copy from here by clicking copy figure. But the standard way of exporting graphics is to use export graphics using PNG and mentioning the resolution. So for example, you can see this this folder. This folder does not have the image currently, but when you execute this section now, when I will execute, you can see that a new image is created, PNG format. So when you double click on this image, otherwise you can do one thing, that you can go directly to your folder in your local PC. There the image will be shown. So you can directly double click here on the image and you can see this image. This is the PNG format image. You can see the quality of the image here. You can check if it is publication ready or not. If you want to increase more DPI, then you can increase your DPI whatever you want, or you can change the appearance. So for example, this is a sine wave, but you can see some abrupt changes in the sine wave. It should be continuous wave, but there are some edges. So these edges are due to the time axis, because I have defined the time axis in the resolution of 0.001. So due to that resolution gap, you are seeing the edges in the sine wave. If you increase the resolution to 0.0000001, a very small value, then you will not get these type of edges. Clear? So this image you can use anywhere in your publication. So this is what I wanted to share with you in today's video lecture. So for example, I want to clear the workspace now. Then I can go to the history and I can press clear all. So when you press clear all, then you can see your workspace will be deleted. Thank you all. If you have any doubts or any suggestions, you are most welcome to ask in the comment section. And any new topic related to MATLAB and Simulink you want to cover me, then you can suggest that also. Thank you.